Hey there everyone, it's Edison Rondilla, your friendly software developer. Apologize for the delay, back with another update on Heroes in My Pocket, Chronicle Forge. If you've been following along, we've covered the project's overview, the key elements like planes, realms, heroes, artifacts, and events, plus the database entities and workflows for both the core and community sites. Today, we're shifting gears into a more technical deep dive. This is the third part of our series, where we get closer to actual development. No more fantasy flair, let's talk code, tools, and decisions like the devs we are. First off, I realized I forgot to include a few crucial parts of the database design in the last video. My bad. So, let's circle back and fill those gaps now to make sure our foundation is rock solid before we start building. In addition to the main tables for planes, realms, heroes, artifacts, items, skills, events, triggers, outcomes, and upkeep, we need some supporting entities to handle relationships and data integrity. For instance, we'll add a rate table to store players' rating and suggestion after venturing on a realm, and other supporting and lookup tables. These aren't just extras, they're essential for normalizing the data, avoiding redundancy, and ensuring efficient queries when the game scales. Think joins that pull a hero's full loadout in one go without bloating the main tables. Now, let's talk front-end choices, because that's where a lot of the user interaction happens in the core site, for creating planes, realms, and all that good stuff. I've chosen Angular for the front-end framework, and here's why. My background is heavily in .NET development, where I've built plenty of apps using C#. Angular feels like a natural fit because it's structured and component-based. Much like how .NET organizes code with services, modules, and dependency injection. Compared to React, which is more flexible but can get chaotic without strict patterns, Angular's opinionated approach, with built-in routing, forms, and HTTP clients, makes it easier for me to ramp up and maintain consistency. No need to bolt on a bunch of third-party libs from the start. It's all there in the CLI-generated scaffolding. Plus, TypeScript integration is seamless, which aligns with my tight language comfort zone from C#. For the HTML part of our Angular components, we'll keep it straightforward. No CSS frameworks or anything else. Just plain HTML5 for the templates, styled with vanilla CSS where needed. This keeps the project lightweight, focused on core functionality, and avoids unnecessary dependencies, making it easier to understand the raw structure. Speaking of Angular, we're definitely incorporating RxJS into the project. RxJS is a library for reactive programming using observables, and it's gold for handling asynchronous operations, like real-time updates when a user adds an event trigger or fetches community realms. Why is it good? Well, it turns messy callback hell or promise chains into clean, composable streams. For example, when a user equips an artifact to a hero, we can subscribe to an observable that fetches the artifact data, processes any upkeep effects, and updates the UI all in a declarative way with operators like map, filter, or switch map. It promotes better error handling and cancellation. Think unsubscribing to prevent memory leaks, and since Angular's HTTP client returns observables out of the box, it integrates effortlessly. We'll use it sparingly at first for things like form validations or API polling, but it'll scale nicely as we add more dynamic features. On the backend side, mostly all of our backend code will be using Node.js. That's right, the core site, community site, and everything in between will be calling APIs built with Node.js. We're leveraging Nestjs as the framework on top of Node.js, which is a game changer for structuring our server-side logic. Why Nestjs? It's progressive and modular, inspired by Angular's architecture, so it uses decorators, modules, controllers, and services that feel familiar if you're coming from a .NET background like me. This makes it super organized. Think dependency injection out of the box, easy middleware integration, and built-in support for things like validation pipes, guards for authentication, and interceptors for logging or error handling. It's great for scalability too. We can build microservices if needed down the line, and it plays nicely with TypeScript for type safety, reducing runtime errors. Plus, the ecosystem is rich with modules for databases like TypeORM for PostgreSQL integration, WebSockets for real-time features in the community site, and testing utilities. For the heavier logic, like the battle system and dice mechanics. That's coming later in development. We'll stick with C# and .NET Core. Why? .NET Core is performant, cross-platform, and has excellent support for async operations, which we'll need for simulating turns in battles or rolling dice with random number generation. For the battle system, imagine a service class that handles turn-based combat, calculating hits based on hero stats, applying skill effects, and resolving outcomes from events. Dice mechanics could use system.random or a more seeded approach for reproducibility in tests. Simple stuff like rolling a d20 for attacks, modified by artifacts. It's all in C#, so we can leverage libraries like MathNet if needed for probability distributions, but we'll keep it lightweight. This ties into our Nodejs layer for real-time, but the core computations stay in .NET for reliability. We won't skip quality assurance either. Unit tests are on the roadmap, though we'll keep them basic for now. Nothing fancy like integration tests yet, just enough to catch bugs early, like ensuring a trigger fires correctly under specific conditions. It's about building confidence as we iterate. As for the tools powering this development, here's the lineup. I'll be using vscode for quick edits and Angular work. It's lightweight, extensible with extensions for TypeScript and Git. For the Node.js backend with Nestjs, vscode shines again with its debugger and IntelliSense, and Visual Studio for .NET development. Postman will handle API testing crafting requests to endpoints like creating a realm or traversing one in the community site, verifying responses before hooking up the front end. And for the PostgreSQL database, pgAdmin is perfect for schema management, running queries, and visualizing those relationships I mentioned earlier. It's a straightforward stack that keeps things efficient without overcomplicating. Finally, once our initial version is up and running, with the core site for creation and the community for sharing, I'll upload the whole codebase to our GitHub repository. That's not just for backups, it's for you all to peek under the hood. Use it as a basis for your own projects or even as learning materials. Fork it, contribute fixes, or study how RxJS streams handle event triggers. It's open for the community to grow with us. Phew, that's a solid technical rundown to kick off development. This sets us up nicely for coding in the next videos. In the next video, we will start delving into the development of the project, hands-on coding, and building out the features. If you've got questions, drop them in the comments. Like, subscribe, and stay tuned. We're building this together. What's one tech choice you'd make differently? Let me know.